Did you know that the path worn into that grass is not the shortest way across it? Look at it. It leaves the concrete at an angle, and then it bends. Nobody planned that curve. It was cut by feet, one at a time, and not one of those people knew they were solving anything. The shortcut in the grass is not the shortest way. Here is the explanation you have heard. There is a corner. You can walk the two sides of it, or you can cut straight across. The two sides are longer, so people cut across, and the grass pays for it. That is true. It is also the least interesting thing about this picture. On a square corner, cutting across saves you 29.3% of the walk. Flatten the corner out, and the saving drains away to nothing. Square it up again, and it comes back. That is where every other version of this stops. Now watch what happens when we add one thing that is true of every lawn on Earth. You walk slower on grass than on concrete. Not by much. Enough. And the moment that is true, the picture breaks. The two routes are not competing on distance anymore. They are competing on time, and those are not the same race. Same start. Same destination. One of them takes the straight line. The other takes a route that is definitely longer because it hangs onto the concrete a little further before turning in. The longer one gets there first. So the straight line keeps its title. It is still the shortest way across. It is simply not the best one, and from here on those are two different words. Everything now hangs on a single number. Where do you leave the concrete? Step off early and you spend a long time in the slow stuff. Step off late and you walk a long way round. Somewhere between those two there is a best place to do it. So let us find it. Slide the crossing point along the curb and keep a running total of the time it costs. Leave too early and you lose 11.4% of your journey. Leave too late and you lose 10.5%. In between, the curve comes down. And it bottoms out here, 19.49 meters along a 30-meter frontage, not in the middle, not where the straight line crosses, nearly 2/3 of the way along. Why there? At the bottom of a curve, the slope is 0, and this slope is made of two pieces pulling against each other. Shift the crossing one step to the right, and you add a little walking on the concrete while taking a little away from the grass. Each of those pieces turns out to be a sign, measured off the line square to the curb. At the bottom of the curve, the two of them balance exactly. The sine of the angle you come in at, divided by the sine of the angle you leave at, equals the ratio of your two speeds. That is the answer. And it came out of a lawn and a stopwatch. Now put the lawn away and draw something else. A ray of light, leaving the air, entering water. It is the same picture. Every line of it. The curb is the surface of the water. The grass is the water. Light goes slower in there, so it bends. By exactly the amount you just worked out for somebody carrying their shopping. The equation has a name. Snell's law, after a Dutchman who found it in 1621 and never published it. Though it had already been written down 600 years before that, by Ibn Sahl in Baghdad. And the reason light obeys it is the reason you do. Out of all the routes from here to there, it takes the one that costs the least time. Fermat wrote that down in 1662, and people hated it, because it sounds like the light has to know where it is going before it sets off. Before we deal with that, here is something the equation predicts that you can go outside and check. Take the destination and drag it away down the lawn. The angle you leave the concrete at climbs and climbs towards 90 degrees. But the angle you cut the grass at does not. It stalls at 54.5 degrees, and nothing you do will push it past. And that is not a fact about one walk. Every track on that lawn, from any door to any gate, is held under the same angle, because the cap is built out of nothing but the two speeds. One lawn, one ceiling, however many paths. Push it the other way instead. Let it rain, and make that grass genuinely bad. The best route bends back and back until you are stepping onto it square at 0.4 degrees, which is the corner. The two sides nobody would walk, at the start of this video, turn out to be the right answer once the grass is bad enough. So run the whole thing backwards on a real one. Measure the angle going in, measure the angle coming out, divide the signs, and out drops how much slower that ground has to be. 19% on this one. Though be careful with that number. This is a photograph, taken at eye level, on a slope, beside a tree. Any one of those three bends a path on its own, and one photograph cannot tell you which did. Call it a reading. Do not call it a measurement. And now the part that everybody gets wrong, including the version of this video I nearly made. It is very tempting to say that your brain computes this, that somewhere behind your eyes a triangle gets solved. It does not, and here is how we know. Look at what the right answer is actually worth. Going from where the straight line crosses to the genuinely best place to cross moves you 4.5 meters along that curb, 15% of the entire frontage, and it buys you 1.1% of your journey. Worse than that, anywhere inside a stretch nearly 8 meters wide, better than 1/4 of the whole curb, you lose under 1%. The bottom of that curve is not a point, it is a plane. So nothing had to solve anything. Here is what happened instead. People crossed roughly where it suited them. Feet wore the ground down. Worn ground is easier to walk on than grass is, so the next person drifted towards it. That is the whole mechanism. No arithmetic anywhere in it, just people who slightly prefer bare earth to long, wet grass. And a track forms, not at the best crossing. Short of it by about 3 meters every time I run it, but inside that flat band, where being wrong is very nearly free, which is the point. The ground was never solving the problem, it was rolling into the bottom of it, and the bottom is wide enough that it did not have to aim. One correction left, and it is the good one. All the way through this I have been saying least time. That is not quite what the principle says. Take an ellipse. Put a lamp at one focus and bounce the light off the wall to the other. Every single one of those routes is the same length. There is no shortest one. There is nothing there to minimize. What is actually true is that the path is stationary, flat, the same flatness that let a lawn answer this without anybody asking the question. And that is why nature lands on it. Light does not pick a route. It takes all of them at once, and everyone arrives carrying a phase. Away from the flat spot, neighboring routes disagree, and they cancel. At the flat spot, they agree, and they add. What survives is not the fastest path. It is the one its neighbors agree with. So that is what you are looking at. Not a shortcut. Not laziness, and not a brain doing geometry behind your back. A stretch of ground where being roughly right costs almost nothing, walked over by enough people that roughly right wore itself into exact. Thank you for watching. If you would like more of this, there is a subscribe button, and it helps more than you would think.